goodness. Good morning. Good morning, everyone. As you come on, you will see a set of data. This is a table chart. And I want you to look at it because today we are going to be talking about scatter plots. So you are going to be using a set of data to graph these points here. Okay? Look at your look at your feed, or look at wherever you get your sheets from. I sent that to you. You should have that. Pull up that sheet. I sent you this. If you got that sheet, put your thumbs up so I know you got it. And then I can put the graph up. This is the sheet that I sent you. So if you got it, give me a thumbs up so I know you got it. This is the table chart. We're talking about weight and we're talking about fuel efficiency. So pull it up and let's look at a scatter plot. Give me a thumbs up if you got it. Thank you, Meridor. You got it. Anyone else has it? Good morning. Good morning, dear. Good morning. Okay, so I'm going to have to write these. I know you can't see. Well, I'm gonna put it like this so we can work on a little bit at a time. Okay, I'm gonna give you 5 minutes to look at this and see what you can do with it. Okay, but I can't. I don't know what to do here. I tell you what. Let's just plot the first 6. The first 6. Let's just use it and see if we can plot these. This is your X and this is your Y. Let's plot these points. Think of it as an ordered pair. Good morning. Good morning. Woo. Good morning, Miss Fitch. Good morning, Mr. Walker. Good morning, all the rest of you out there. Good morning, Jordan. Money. Good morning. Let's move right along. Our time is of essence, and it always gets away from me. So let's move right along. Okay? Now, let me see. Okay. When we look at this and we are talking about a scatter plot, we are talking about plotting points that will be, it does not start with zero as most graphs do. They start with zero and then you do whatever you have to do and graph the ordered pairs. But here, according to where it falls, this is what we do. So a scatter plot is when two numerical variables are graphed by using one variable as the x-coordinate and the other as the y-coordinate. Now, when we look here, you'll see that you got x and you got y. So it says the table below shows the weight of efficiency for 13 car models with automatic transmissions manufactured in 2009 by Chevrolet. Now, when we look at these points for car 1, 13 car models, model 1, you had a weight of 3,200 and the fuel efficiency miles per gallon, it gave you you could get 23 miles per gallon for that. So 32, and we look at that as 32 miles per gallon at 23. So our weight is 32, somewhere right in here. And 23 gonna be right up in here somewhere. So I may not be exact because I'm freehanding. That's my point. 2,550 fuel efficiency miles per gallon. It gives me, with a weight, a car with this weight will give me 28 miles per gallon. I can go 28 miles on fuel, a gallon of fuel. So 2,550 would be somewhere right in here, and I'm going 28. I can go about 28 miles, somewhere in here. And 4,050, 4,050, okay. 4,050 right in here, and I can go 19. Somewhere in here. Same thing. At 4,050 on the fourth model, I can go 20 miles. So it'll be somewhere right in here. I'm going 20. 3,750 for the fifth model. I can go 20. So that's gonna be somewhere right up in here. And 3,550 for 22. 3,550, I can go for that model. It gives me 22 miles per gallon. Okay, let's say that. Okay, now we can't see all these points at one given time. So last one was 20. So 3,500, I have the sixth model, I can 1, 2, 3, 4, 5, 6. No, I'm on the seventh model. I can go 19. So 3,550, I can go 19 on that model. Same thing, 3,550, I can go 25 on model 8. So if I can go 25, I can go somewhere up in here. And model 9, 4,600, I can go 16 miles. 4,600, 4,600, right in here. I can go 16 miles on that model. So, somewhere in here. 5,250. I can go 12 miles. I can go 12 miles right on that one. 5,250 on 10. 5,250. I can go 12 miles. And 11, 5,600, 16 miles. 5,600, 5,500, 5,600, somewhere right here. I can go 16 miles. I can run about 16 miles. I can get about 16 miles per gallon on this car. And Model 12, I can get 4,500. It weighed 4,500 pounds. I can get 16 gallons out of that. So 4,500, I can get 16 gallons. So somewhere right along in here. And 4,800, I can get 15. 4,800, I can get about 15. Look at the relationship here. We said it was a relationship. Look at it. Is it positive, negative, or no relationship? A positive relationship is when your points are increasing. As your X increase, your Y increase. For example, it looks like this. I didn't want to write on this, but it looks like this. This is a positive relationship when it comes to a scatter plot. Like this is Y, this is X. And if it's positive, you will notice that your points are going up. So as the X increases, what does the Y do? It increases as well. So the Y increases. X-axis increases, the Y-axis increases. But if it's a negative relationship, what you're going to see here is that your points going to start going downward. They're going to follow a downward pattern. You know, let's say they look like they're going down. So that's a negative relationship. Now, no relationship at all. These are the types of relationships. If it's no relationship, your points are going to be scattered. So then, that's a no relationship. Okay? So that's how you tell the difference. Your positive ones, that's a positive relationship because your points going to be going up. And your negative one relationship, your points going to look like it's going down. There's no relationship when you see it all everywhere, scattered everywhere. There's no relationship. So if you were to look at this, would you say then that this is no relationship, negative or positive? What you think that might be? Let's think about it. If we were to continue, does it look like your points are going down? Or does it look like it's going up? Or does it look like it's scattered everywhere? Look at it. It looks like it has more of a negative effect. If we were to continue, it will look like it appears to be going down and not up. And it's not all over the board. Okay? Let's move on. Okay. Any questions? Any questions on that? Okay. I want you to think back from our last visit. We didn't get very far. So I'm going to review something. We were talking about the rate of change. And we were talking about the slope. What was the slope of that particular line? Okay? This was on page 22 of packet 4. This came off of page 22 of packet 4. That's what we're going to try to finish today, and then continue with what I just did came out of packet 5. That was packet 5, what I just did on slope. But because we are so far behind on packet 4, I'm going to try to catch up a little bit of that too, and then I'll get back into packet 4. But packet 4 deals with scatter plots. Okay, now, page 22 of packet 4, we were talking about, suppose that the price of gasoline had been falling. And they told you at the beginning of the month, it was T equals 0, the price was $3.80 per gallon. And 20 days later, T was 20. The price was $3.20 per gallon. It says, assume that the price per gallon fell and the constant rate over 20 days. So it asks you, what is the rate of change? And what does it mean within the context of the problem? And Momo was talking to us on last visit, and she told you that the rate of change was a negative 0.03. Now, I want you to know how you got that. A negative 0.3, what you had to do is look at your slope formula. M equals y sub 2 minus y sub 1 over x sub 2 minus x sub 1. That's how you had to do that. So what you do, you look at your ordered pairs and you just plug in your information. For example, if I know this is 0 and this is 3.80, I know this is 20 and this is $3.20. I know this is x1, y1, y sub 1. I know this is x sub 2, y sub 2. So what I do here, I just plot this information into the formula. So now I know y sub 2, I go up here and get its value. Y sub 2 is $3.20. So I say 3.20 minus y sub 1, and y sub 1 was 380. So I say 380. And then after I find that, then I want to know what is x sub 2. X sub 2 is 20 minus, because we're just plugging into the formula, x sub 1, and x sub 1 was 0. So then I subtracted 3.20 minus 3.80, and what do I get? 3.20 minus 3.80. What am I getting here? A negative 0.6 equals a negative 0.6 over what? 20 minus 0 is 20. So if I were to divide that, I know my answer is going to be negative because this is a positive and that's a negative. So if I were to divide that, I will get a negative 0.03, I believe. So that was our rate of change. And that's how Momo came up with that answer. I don't know if you all, picked that up or not, because we didn't talk about the formula, the slope formula. M equals y sub 2 minus y sub 1 over x sub 2 minus x sub 1. So the rate of change was a negative 0.3. Okay. Now, so you know the rate of change is the same thing as your slope. Moving on. What I want you to do, are there any questions with that first? Are there any questions on that? There any questions how we found that slope or rate of change? Okay. Now, I would like for you to look at packet 4 and go to page 24. I got to try to go through all these pages today, so you will be able to do the other part on your own after we do this piece. Okay? If you get page 24, packet 4, give me a thumbs up. Give me a thumbs up if you get that. Got it? Packet 4. Packet 4. Page 24. That's what I got on my page. Page 24 of 39. We're talking about Gina. I sent you all these sheets last time. Gina bought a used car for a blank. Okay? Look at it. All right. Thumbs up. Got it, y'all? Do y'all have that? Give me a thumbs up. I don't see but one thumb up. So it's packet 4, page 24. And it's about Jenna. It says, it's talking about the value of the car in dollars. The value of the car in dollars starts with Jenna. Jenna bought a used car. Packet 4, page 24. Packet 4, page 24. Come on, y'all. This was from week 4, page 24. That's what I had on mine. Now, I don't know if you got the same thing on yours, but that's what mine said. And it starts with talking about the value of the car in dollars. Y'all got that? It says Jenna bought a car for, let's say, $18,000. Let's say Jenna, give me a thumbs up if you got it. I don't see but 2 thumbs up. 1K. Okay, someone says page 21 in your packet. Mine says 24. Okay? All right, now. That's okay if you turn yours in. If you turn that in, what I do, I just, one person said they had turned it in. So therefore, I just run through it for the rest of you because we didn't do none of this on last visit. And then I go back to talking about scatter plots. Okay? All right, now. It says Jenna bought a car, a used car. Let's say for $18,000. So let's say we got a car here. We purchased this car for $18,000. She has been told that the value of the car is likely to decrease by $2,500 each year. So that the car going to decrease. The car will decrease each year by $2,500. Let me see if I got another marker here that's not doing the job. The car will increase each year by $2,500. Let the value of the car in dollars be V and the number of years she has owned the car be T. So V stands for the value of the car. T stands for number of years she owned the car. Okay, what is the value of the car when she purchased it? What was the value of the car in dollars when she purchased it? Drop it in. What was the value of the car? What did she pay for the car? What was her initial value? What she paid in the beginning, what did she pay? What did she pay for the car? Let's say you purchased a car. How much did you pay for that car up there? I know my car looks bad, but how much did you pay for it? Huh? How much did you pay for that car? $18,000. Not $1,800, but $18,000, okay? So if you purchased $18,000, if you gave me $18,000 for a car, and your car decreased each year, that means that every year the value of your car is going to be more or less. If it decreased, it's going to be less in value. So then a car depreciates, not appreciate. Okay. Now, it says, show this point on the graph. If you had a graph, let's say you had a graph, and this was Y, and this was X, 0. And number of years you had the car, and what is value of the car? Number of years, and this is value of the car. Okay, we said let T be the value of the car. So T would have been here. V for the value of the car, I'm sorry. And T would have been here. The number of years you had this car. Okay? So now, if I were to ask you to show me by points on this for $18,000, if I ask you for the order pair of this, there is no X value here, because this is the initial value, and the initial value is your Y. So there is no X value here. And if I ask you for a set of order pairs, you will have 0 and what? 18,000. Because you got to have an X. If you had an X, if you had a Y, this X and this Y. You don't have an X. You just had an initial value, which is your Y value. So Nan says, what is the rate of change? What is the rate of change that relates to it? Is it positive or negative? Remember, how much did it decrease by? Remember, how much was it decreasing each year? So if her initial value was $18,000 and it decreased that year, so that'll be 18,000 minus what? 2,000 what? $500. How much is her car after 1 year then? Drop it in the box. How much is her car? How much would that car be? What would the value of that car be? After 1 year, what's the value of that car? I gave you $18,000 for a car. After 1 year, I want to know what's my value of that car, because I want to sell it. So now when I went for my value of the car, how much is that car worth now? I initially gave you $18,000 each year. For after 1 year, how much is my car worth? Is it still $18,000? What is it? How much is my car? Come on, somebody. Anybody want to join my live? I know you know it. Come on. Thank you. Woo. Can't say it. I know who you are, though, Lonnie. Lonnie says it was $15,500. Why you change your mind to $500? You had it right. So 18,000 minus 250, 2,500, going to be $15,500. So the value of my car now after 1 year. All right, let's say I kept that same car for 2 years. What's the value of my car then? I had it 2 years. What's the value of my car? I gave you $18,000 for it. And I went 2 years with this car. Now I want to sell it to Thalani. I can't say it, but anyway, I want to sell it to you. What would I be looking for in my value of my car? I had it for 2 years. What's my value? How much is my car worth? So that'd be, what is my car worth, y'all? What is my car worth after 2 years? Golden Nuggets on the ball. I love Lonnie. Okay, on the ball, y'all. $13,000. This is how much this car here now is worth. So now you see that my car is going down in value and it's depreciating. Depreciate means that it gets lower. Your value is not as high. It gets lower. That's why people tell you, buy a house, appreciate. Car, depreciate. Means the value drops. House, value goes up. You pay $5,000 for it. In 10 years, you got more money. 50,000. I'm just saying. So it goes up. All right, now. One more in 7 years. What will my car be? I kept it for 7 years. I'm going to jump to 7 years. What was 7 years? And I'm not going to tell you. Tell me what's the value of my car in 7 years. What's the value of that car in 7 years? What would the value be in 7 years? How much is my car worth? I want to sell that car back to some of y'all. Come on, who wants to buy it? Look at that nice car up there, $18,000. I paid for it, initial value. Now I want to sell it back to you. Some of you, one of you. How much would my value be? Can I now tell you that I want $15,000 after 7 years for that car? What you think? How much would it be? How much can you give me for that car now? If I'm looking for, we're talking about, you tell me, Miss Green, let's go by the book value of that car. What would the value of my car be now? It's 7 years down the road. 7 years down the road. No, not no $6,000. Okay, here's what you're forgetting to do. 7 years down the road, I told you for every year, it depreciated or decreased by $2,500. So now I went 7 years. So how much is 7 times 2,500? 2,500. Yeah, how much is 7 times 2,500? First, you got to find that. $2,500 for every year, and 7 years went by now. Now what I'm going to do? I paid you $18,000 for the car. Now the car is depreciating. It's now, I've lost a value of $17,500. So what I got? How many dollars I got left? Equals what? That's all my car is worth after 7 years. So it went down, it depreciated. Okay? Thank you, young boy Reek. Thank you. I already had the answer. Thank you very much. Let's go to sheet 25 real quick. Get sheet 25. I don't know if yours is 25 or not. It says write the linear function that models the relationship between the number of years Jenna has owned the car and the value of the car. What's the linear function? Write the linear function that models that. Okay? What would your linear function be? models the relationship. You have to give me an equation. So the value is equals to 2,500 T plus, this is my rate of change. Every year it went down. So that's a I could either do it like that, or I could say value is equals to $18,000 minus 2,500. I can do it that way. I can write either or. So that's my linear function. All right. It says an online bookseller has a new book in print. The company estimates that the book is priced at. Then copies of the book will be sold per day, and the book is priced at blank. The copies then will be sold per day. Okay, I'm gonna try to model this as best as I can, but it's kind of hard to look up here and do this. So you got a graph. We're talking about online bookseller. Let's get rid of this. It's not related to that. So cost as sold per day. So your cost as sold per day and let's say it's 100. We can count by hundreds. 200, 300, 400, 500, 600, 700, 800, 900. And an online bookseller has a new book in print. The company estimates that a book is priced at how many ever dollars per day? So this is the cost, and these are the number of days. Let's see. Let's see, 0, 15, 16, 17, 18, 19, and 20. Let's say that I ask you to identify the order pairs for 15 days. I told you that the order pairs were 15 and 800. And I also told you another set of order pairs were 20 and 550. If I told you that, how would you graph that on this graph? Which would be your X and which would be your Y? What would your points look like? What would your lines look like? If you were doing 15 for your X and 800 for your Y, 20 for your X, 550 for your Y. Graph that real quick on your paper and tell me what your point or where your points will be. Okay, if you were graphing this in 15 and 800, you know that 15 gonna be here and 800 here, so then you know your point is gonna be here. And if you did 20 and 550, your X is 20, your Y is 550, so it's somewhere in here. Well, if I were to draw a line, we'll talk about a linear, it'll be looking somewhere like that. So, then on your sheet, it asks you What is the rate of change relating number of copies sold to price? So between the points, between these 2 points, what's your rate of change? Use the formula. You can also use the formula M equals y sub 2 minus y sub 1 over x sub 2 minus x sub 1. If you were to plug in that information, you notice it's x sub 1, x sub 2, y sub 2, y sub 1, x sub 2. So if you were to do that, what would your answer be? What would be your run and what would be your rise? Your run, your rise over your run in the slope formula is equal, it looks like that. So what would you say? Y sub 2 would be 550. Y sub 1 going to be 800. And x sub 2 is 20. X sub 1 is 15. So it asks you what's your run. This bottom number is your run. So your run going to be 5. And what's your rise? This going to be your run. And this right here going to be your rise. So what's the difference between 550 and 800? You know 800 is the largest number, so it's going to be a negative something. Negative what? 250. So it should be a negative 250 over 5. And your run is 5, and this is your rise. You have to know the formulas for slope. This is 1, and this is 1. And then you can use y equals mx plus b. It's whatever they are asking you to do. But in this particular one, the run is 5. And the rise is a negative 250. Okay, now, let's see if there's anything else. Okay, if I ask you on page 26 of 39, it said based on the graph, if the company prices the book at a certain amount, how many copies of the book they expect to sell? So if they wanted to price the book at $6.50, how, according to the graph, how much? About how many copies of the book they can expect to sell per day if it were 18 days. Okay. I know. The problem is we didn't plot all of these. So let's say I'm gonna give you a little more information because we didn't plot all of the points. So let's say 18 and 650. We should have already plotted that. I should have given you that so you could have already plotted it. So for 18 days, it would have been 650. So it would have been somewhere like right up in here. And you would have drawn a line like that. So if I ask you how many books that they expect to sell in 18 days, you would have automatically known it was 650. We didn't complete the graph in its entirety. So, okay. And if I had told you in 17 days they were going to sell 600, it would have been, it would have been something like that in 17 days. The graph would have looked like that. So if I had asked you a question, how much would they get for 18 days, you would have known that it would have been 650 by me giving you that particular information, $650. Okay? So what price should the company sell or based on the graph, approximately what price should the company charge in order to sell 700 copies? Based on the graph, approximately what price should the company charge in order to sell 700 copies? Oh, this is supposed to be price. That's supposed to be price. So what price would they sell? What price should the company charge in order to sell 700 copies? We didn't do that either. So I'm going to leave that alone. I'm not going to ask you that question. So I just did it here so you know that they would charge $17 in order to sell for 700 copies would be $17. But I had not drawn the graph, so. Okay. Let's get away from that because that's kind of hard to explain, drawing this and that and graph like that. What I do, I just put it on, I post it out for you and give you copies of that because it's kind of hard to do that just by standing right there. All right, now, let's go back to the scatter plots. Let's go back again to scatter plots. Ooh, shucks, my time is gone. Remember, I told you a scatter plot had different relationships. I told you it was positive, negative, or no relationship at all. And remember I said positive was when it was going up. And I told you negative was when it looks like it's basically coming down from the Y value to the X. And I told you that it's no relationship when it is scattered everywhere. So knowing those two things, I already labeled the vertical axis of the scatter plot. So it says, if a compressed, what would the vertical axis be? Compressed rubber spheres. We could label this as compressed rubber sphere. So, okay, if a compressed rubber sphere has a 6-inch width, meaning that it was 6 inches wide, is its height closer to 5 inches? Is its height 6 inches wide? Would its height be closer to 5 inches or to 11 inches? Explain your reasoning. If a compressed rubber sphere has a 6-inch width, if it's compressed, it's sort of tight together, like pressed down, compressed, do you think that its height will be closer to 5 inches or to 11 inches? Explain your answer. I would think that it would be closer to 11 inches because when you let go of it, it should become higher. So 5 inches, it already has a height has 6 inches width, and I think that it will be higher. So I would say it would be 11 inches. It says, describe the pattern that you see. What happens as the horizontal width increases? As the horizontal line running this way, as it increased, what happened? Its height got what? The height was shorter as it increased. As the horizontal width increased, as the width of it increased, look how your dots dropped. It wasn't high, it was lower. Okay. I'm sorry, y'all. Over my time again. So therefore, what I'll do, I will post all the other answers online for you because it's kind of hard to explain all of that in detail standing right here. So therefore, I'll send you those copies and you can fill in your information. And thank you very much. I'm over my time. Thank you. All right. Thank you. Bye-bye.